This is the Math 2 Unit 10 review worksheet where we're looking at quadratic functions, graphing parabolas, and solving in vertex form as well as solved by factoring. So first off, we start with our graph of f of x, and we're going to make true or false statements looking off of this graph. So we don't really need to know the equation or the function of the graph, but we can at least start to see some information. So first off, f of x is decreasing when x is greater than 0. So if we look at when x is greater than 0, so that's on the right side of the graph, it is in fact decreasing because the graph is going down. So that is true. The axis of symmetry is y equals 0. Now y equals 0 is when all y values are 0, and that is a horizontal line. So that is false. That is not the axis of symmetry. If we jump ahead, that's very similar to question H down here. The axis of symmetry is x equals 0. Now x equals 0 is the line when all x values are 0, which would be the vertical line, basically the y-axis, which is our axis of symmetry. So that one is true. So be careful with that. And sometimes in questions we switch out the x and y, and you got to pay attention to what you have. The maximum value of f of x is 9. So that tells us right here it hits 0, 9. So that is its maximum. That's true. 2, 5 is a solution. So if I go over 2, up 1, 2, 3, 4, 5, it does appear that that is a solution because that is a point on the graph. Negative 1, 3. Negative 1, 3 puts us there. That is not on the graph of our parabola, so that is not a solution. That is false. 3, 0 is an x-intercept. 3, 0 would be right here. That is an x-intercept. That is where it hits the x-axis, so we'd say that is true. 0, 9 is an x-intercept. Well, 0, 9 is up here. That is where it hits an axis, but that is not where it hits the x-axis. That's where it hits the y-axis, so that is false. The vertex is 0, 9. We're good with that. That's true. Pay attention to the vertex, and the maximum or minimum value are always at the same point for a parabola. The value of x when f of x reaches its maximum. So when it reaches its maximum of 9, the x value is 0, because that's the x value in our vertex. So that is true. Okay, some other parts we need to know. The domain of f of x is going to be all real numbers. And that's because we could put any value in and it gives us a point on the graph of our function. So domain is all real numbers. The range of f of x. Now that is not all real numbers because since 9 is our maximum, there's never going to be a value above 9. So we're going to say that it is range, we're just going to say less than or equal to 9. Less than or equal to 9. If we want y values, we could say the y values that are less than or equal to 9 would work as well. It is going to hit 9. It's not a just a less than, but a less than or equal to. All right, so determine the rule for translating g of x equals negative x squared to f of x. So what happens when we do a negative x squared? Now a negative changes the direction that the graph opens. So what that's going to do to us is it's going to take the x values, keep them the same, but then make it a negative y value. And it's going to be like a reflection across the x-axis. All right, so now moving down, we have part 3 here. We have some table values for k of x. We can plot them, and then from that we can go in and answer its information. So I'm going to first plot them. So as I did that, I actually ran out of space up here, and so I kind of extended it up, and this is our parabola. Now if I notice my vertex, the biggest value I get is at negative 2, 9. So that's probably going to help me. It hits the axis here at 1, 0. It hits this one at negative 5, 0. It hits here at 0, 5. Some things that might help me as I go through. So first off, the x-intercepts of k of x. That's going to be 1 and negative 5. So 1, 0, and negative 5, 0. The y-intercepts are at 0, 5. The value of x when k of x is at its maximum. So that is the x value from the vertex. So that's negative 2. And then the maximum value is its y value. So that's 9. Now, at the vertex is when it changes direction. So when we're talking about increasing, decreasing, we're going to go off of that value, so negative 2. So the k of x is increasing when x is, so it's increasing on the left side of it, so when it's less than -2. It's then decreasing when x is greater than -2, when that's on the right side of it. All right, moving down to number 4. Match the equation to the number that reveals the characteristic without changing the form of the equation. So I always like to first start off with vertex form. Vertex form, which is C here, gives me the vertex, which is also the minimum or maximum. So that means these two match up. After that, I have this form in part A, which is called factored form. The factored form give you the factors, which give you the solutions, or what we call the x-intercepts, or the zeros, which is this form. So the last one, B, which is what we call standard form, reveals the value of m of x when x equals 0. If I put x's in, x equals 0 in, it really gets rid of that quickly, and I get 15. So we're there. So 1, I guess we could say A goes to 2, B goes to 3, and C goes to 1. And that's how we match them up. All right, moving down. So we're going to look at factoring and fill in the boxes that we have. So it's really, we have this extra distraction. You have to factor to figure out what we have. So what's going to multiply? I'm going to go 2 and -15. So what multiplies to -30, that adds to 7. So if I'm thinking of -30, I can do 3 and 10. And I want a +7. So if I make 10 positive and 3 negative, together they're going to multiply to be a negative product, but a positive sum. So that's going to work. So I'm going to go 2x squared minus 3x plus 10x minus 15 equals 0. I can take out an x from the first two. I could take out a 5 from the next two. They both have a 2x minus 3, so I factor that out, and I'm left with x plus 5, and that gives me my factors. Now that is factor by grouping. That is what we did in the previous unit. That was the main focus there. We can still apply it here because now we're solving from this later on. So we go 2 minus 3, 1, and 5. Come over to this problem. We're going to factor as well. So what multiplies to 50 that adds to 51? Oh, -51. Well, 50 is 1 times 50. And if I make it both negative, they'd add up to be a -51, but they'd multiply to be a positive. So we're going to go 5x squared minus x minus 50x plus 10 equals 0. I could take out an x from the first one. I got 5x minus 1. I can take out a -10, and I get 5x minus 1. So it's 5x minus 1 and x minus 10 are my factors. So I go 5 minus 1, 1, and -10. Right, moving on. For number 6, we need to state the vertex and determine whether it has a minimum or maximum. So in vertex form, it's a x minus h squared plus k. We're going to take the opposite of the value inside the parentheses with the x, and then the k value is our y value. And after we do that, once we have the vertex, what value as out in front is going to determine if it's a minimum or maximum. If this is positive, it opens up, so we'd have a minimum. If it's negative, it opens down, so we'd have a maximum, kind of like this idea. This would have a minimum, that would have a maximum. So, first one, my vertex, I go opposite of the -5, so that's 5, 2 is my vertex. It's negative, so it opens down, so I have a maximum at that coordinate. Next point, it's going to be 5, 2. Change the 5, keep the 2. This is a positive value out in front, so it opens up, so I'm going to have a minimum. Third one, x plus 5 is on the inside, so it's going to be a -5 and a 2. This is positive, so it opens up, so I have a minimum at -5, 2. For 7, it's very similar to what we just did with the vertex, but the axis of symmetry is the x value. So whatever this is, the x value, is that line we draw that gives us the symmetry that's going to be on the vertex. The vertex is going to be on that line. So the axis of symmetry is x equals -1. So we change the sign to make it there. What you can also think of is what's going to make this parenthesis be 0. So if I put a -1 in here, it's the opposite, and that works for it. So then on B, we have x plus 5. That's going to be x equals -5. And then x plus 4 is going to be x equals -4. So that is the line or the value where the axis of symmetry is, but really it's also the x value in the vertex. All right, for number 8, we need to determine if the ordered pairs are solutions to the function. Now this doesn't mean x-intercepts. This means is this point on the graph. So what we did in the beginning, right here, is we had a couple points we checked with, and that was if it's a solution. So we can also do that by just taking the function and substituting in for x and y to see if it gives us a true statement. Remember, we got x, y. So we're going to go first one, -3x squared plus 1. That's going to be 1 equals -3 times 0 squared plus 1. Well, 0 squared is 0 times -3 is 0. So we get 0 plus 1, and that becomes 1 equals 1. So that is a solution. For 2 and 37, we're going to go 37 equals -3 times 2 squared plus 1 gives us -3 times 4 plus 1. Now we're at -12 plus 1. Is that equal 37? Does not equal -11. So, not a solution. 2 and 11. So now we're going to go 11 equals -3 times 2 squared plus 1. That's -3 times 4 plus 1, which is -12 plus 1, which is -11. We have 211. Is 11 equal to -11? That is not, so that is not a solution. Last one, 1 and 8. So we're going to go 8 equals -3 times 1 squared plus 1. We get -3 plus 1, which gives us -2. 8 is not equal to -2, so that is not a solution either. Now we're down at number 9. So we're looking at our graph, and we have to go through and identify information. So we've looked at our graph. Before I have to find this values, I see that I have a vertex here at 0, 5, so I'll use that. Not really sure where it hits the x-intercepts there, so I'm not going to make a for sure guess on that, but it does open down, so maybe that'll help me for the values. So I need to find the vertex, 0, 5. Is it a minimum or maximum value? It is a maximum, and the maximum is 5. Now that's when y equals 5. The axis of symmetry is what line do I draw to cut this in half, and that's going to be when x equals 0 because it's the same x value as in the vertex. The graph is increasing, so it's using x and 0. So which side of it? So if I cover it up and think of the positive side, so that's anything to the right of the line of symmetry, it is decreasing there. So it is decreasing when x is bigger than 0. That means it's increasing when x is less than 0. Okay, on to number 10. We have f of x equals x squared, so that's just our normal x squared right here. G of x is at x plus 4 squared minus 2. So I went, vertex would be -4, -2. So let's move over 4 down 2. And that is g of x. So we need to describe the transformation. So that's going to be that xy moves, so we would take all the x values and subtract 4, and all the y values and subtract 2. So that's the notation we could use to describe that shift. We could also say it's a translation of 4 units left and 2 units down. Still opens in the same direction. It's not a reflection, but it did do that translation shift. Okay, next one, we have f of x is x squared. We'll put that there again. Okay, our new one, g of x, goes to a vertex of 3, 1. So it goes over 3 up 1, so here's g of x. So xy goes to x plus 3, y plus 1, which would be a translation of 3 units right and 1 unit up. So for number 12, we now are comparing two functions. This is f of x, this is g of x right here. So one is a graph, one is a table, and we have to go through and compare them. So I'm not going to sketch out this entire graph. I'm just going to find some important pieces about it and then kind of put it on here to give it perspective. So I know that if I look at g of x, it's at -6, -2.5, 0. So it's going up, 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 and then here it suddenly turns and changes direction and goes back down. So that tells me that the vertex is at 3, 2. So I'm going to go over 3, up 2. I also know since it was going up, it's probably opening down. It's not perfectly to sketch, but it at least gives me something to start with for g of x. So which one has a greater maximum value? Well, g of x does. It's above f of x. Okay? The x value when g of x is at its maximum is greater than the x value when it's at its maximum. All right, well, it's at its maximum at 3, 2, and this one is at its maximum at 3, 2. It's no, because they're the same. Now the x-intercepts of g of x, I didn't sketch this perfectly to scale, but the x-intercepts are when g of x equals 0, which is at 1 and 5. So we're going to say when x equals 1 and x equals 5. Now f of x does not have x-intercepts because it doesn't hit the x-axis, and that's perfectly fine. That's something we'll more worry about later, but we can at least find that for g of x. All right, 13, we need to state the zeros. So we're going to solve by factoring. So I'm going to make 0 equals x squared minus 5x minus 14. And I'm going to think what multiplies to -14 that adds to -5. Well, 14 is 7 and 2. One of them has to be negative, and for it to be -5, I need the bigger one to be negative. So -7 and 2. So that's going to be x squared minus 7x plus 5x minus 14, which is going to be, I'm going to take out an x, and I get x minus 7. I take out a, oops, I should make that a 2. Take out a 2, and I get x minus 7. So my two factors are x minus 7 and x plus 2. So now I set them both separately equal to 0. X minus 7 equals 0 gives me x equals 7. And x plus 2 equals 0 gives me x equals -2. So my two zeros would be -2 and +7. For number 14, we have a ball is thrown in the air represented by this equation where we have the height and the time. So I'm just going to sketch this out. So first off, I look at this and I see a vertex of 3, 23, and I see this opening down. So it's probably looking something like this. Not perfectly to scale, but at least gives me an idea of what I'm looking at. H of t is the height, and then t is the time. So how long does it take for it to reach its maximum height? So I know time is this axis, so it's going to be the x value in this scenario. To reach its maximum height, it took 3 seconds. Now, what is the domain? So the domain is going to be when does this problem matter? So when does it hit back here? Because I know it's between 0 and something. Because like before that, it didn't matter. So for that, we're going to have to solve and find the other solution. So we're going to go 0 equals, let me get another piece of paper. So we're going to go 0 equals -3, t minus 3 squared plus 23. We're going to subtract 23. We're going to divide by negative 3, which makes it 23 over 3 equals t minus 3 squared. We're then going to take the square root of that, which becomes plus or minus the square root of 23 over 3 equals t minus 3, and then add the 3 over to get this very complicated answer for t. Now, normally the numbers work out nicer. They didn't here. So let's just use a calculator and see what we get. So the square root of 23 over 3 is about 2.7, let's say 2.77. So we got 3 plus or minus 2.77 equals t. So in that case, I want the positive solution. So we're going to go 3 plus 2.77, so that's going to be 5.77. If I did the minus, it gives me like negative, not negative, it's a positive, but it's really small, 3 minus 2.77, 0.23, and that's saying like when the timer was started, the ball hadn't quite left yet, it was thrown in 0.23 seconds. The important thing is we want to know that value, so that's 5.77. Now, the range is going to be a little bit easier. So the range is saying, well, what's the lowest value, y value, that matters? And that's 0. Because when it hits the ground, we're not going to keep looking, because it's not like it goes through the ground and keeps going. So now, how high does it go? Well, the maximum height that it reaches is 23 feet. And so that's going to be 23 feet. So, domain, just keep in mind for the context of this problem, we want to think from the x value, kind of in that positive area, the top right quadrant, the positive x values. And then for the range, it's from the x-axis up to where it reached its peak. And you know that, you can find the domain and range. All right, moving on, let's graph some more. So we have in vertex form, we can first find our vertex here is -1, -2. The domain, we know it's just a graph, it's going to be all real numbers. When if it was a word problem, we'd have to worry about the context of the problem, it could be positive or negative, so we're good here, all real numbers. The range, now if we think of this one, we'll graph it here in a moment, but it's going to be opening down, so it's going to be y is less than or equal to the biggest y value it has, which is -2. And the axis of symmetry is when x equals the x value. So now we can go to sketch. So I know I'm going to go to -1, -2. If it opens down, we can kind of cheat here. The -2 is how much it goes down 1 unit on either side of the vertex. Now, this doesn't help us with other points outside of that, but it at least gives us a good hint for the sketch. So it goes down 2 units on either side of it. Now, it doesn't keep going 2 units, because then that would be a constant change, and this would look more like an absolute value function, which it's not. It gets steeper, but it's enough to just give us an idea for the sketch. Next one. Now the next one, this is in standard form. This is not what we typically deal with, but it's saying x-intercepts. So let's solve for the x-intercepts. So I'm going to go 0 equals -x squared minus 4x minus 3. I'm going to take out, well, let's do this. Let's multiply. So what multiplies to 3, that adds to -4, and that should be -3, -1. So we're going to go -x squared minus 3x minus 1x minus 3. We can take out a -x and leaves us with x minus 3, or x plus 3. We can take out a -1 and that leaves us with x plus 3. So our two factors are x plus 3 and -x minus 1. Now we set those equal to 0. So we get x is -3. And -x minus 1 equals 0, we get x equals -1. So -3 and 1, -1, are the x-intercepts. All right. Now let's figure out where the vertex is off of that. So if I'm at -3, -1, and that's where it hits. The vertex is going to be halfway between it because it's symmetrical and it's the middle line. Now I also could look and think, well, is it going to be above or below? The fact this is opening down probably means the vertex is somewhere up here because it's going to open down from that. What we could also do is just substitute in -2. So if we substitute in -2, we can find the value. So we have -4 plus 8 minus 3, which is -4 plus 5, and we get 1. So that gives us the coordinate of -2, 1, which is our vertex. It opens down. Axis of symmetry is at x equals -2. We can cheat here a little bit and make the x's 0, and that gives you -3. So that tells you actually that's your y-intercept, which is something we're going to look at next unit. But it gives me another point to then sketch the graph. Okay, same idea on this one. We're going to factor. So we've got 0 equals x squared minus 4x minus 5. What multiplies to -5 that adds to -4? That's going to be 5 and -5 and 1. So x squared minus 5x plus x minus 5. Take out an x, so we're left with x minus 5. Leave it as 1. Take out x minus 5. So we got x minus 5 and x plus 1. So x minus 5 equals 0 gives us that x equals 5. And x plus 1 equals 0 gives us that x is -1. So those are our intercepts. So -1 and 5. Now if that's the case, our axis of symmetry is halfway between them, which is going to be right here when x is 2. So if I know that's the line, I now just need to find the vertex. So when x is 2, I'm going to substitute in 2 squared minus 4 times 2 minus 5. We get 4 minus 8 minus 5. That's 4 minus 13, which gives me -9. So down here, past the graph, we have 2, -9 is our vertex, and we can sketch our parabola from there. All right, back page. Here we go. F of x equals x squared, and g of x is 3 to the x. We need to find the average rate of change for 0 to 3 for both of them, and then start to look at the differences from them. So if we have x squared, we're looking at 0 and 3. If x is 0, x squared, we get 0, we get 9. So our average rate of change is actually the slope between those. So I'm going to do 9 minus 0 over 3 minus 0, because it's the change in y, or the change in the f of x, over the change in x. So that's 9 over 3, so my slope is 3. That's my average rate of change. For g of x, which gives me x and 3 to the x, I have 0 and 3. 3 to the 0 is 1. 3 to the third, 3 times 3 times 3 is 27. So here we're going to do the slope, which is average rate of change. That's 27 minus 1 over 3 minus 0. We get 26 over 3, which we know is a little bit less than 9, because 27 over 3 would be 9. It's going to actually be 8 2/3, or it's about 8.6 repeating. Any of those would work. So what do the average rates of change tell us about the functions? Well, we know that g of x is steeper from x equals 0 to x equals 3. It has a larger rate of change, higher rate of change. It means it's going to be a steeper line. Now, how are the average rates of change different? Well, one's one value, the other's a different one. Why? Well, they're not the same type of function. So x squared, which is a quadratic, and 3 to the x, which is an exponential, they're not the same type of function, so their rates of change will be different. Hopefully that answers it for you. All right, almost last set here, 19. We have the graph of h of t equals negative 16 t minus 1/2 squared plus 36. So this is graphed for us. Our vertex, it looks like, is at 1/2, 36. Okay, it's looking good. We got to just answer some true-false questions. So I like looking at the vertex. Here's an x-intercept at 2, 0. Looks like this is hitting about 32. So just kind of planning out questions we may have. So the maximum height of the rocket, that's the y value in the vertex. It is 36, so that is true. The maximum height is 2 feet. That is wrong. That's going to be the time it spent in the air would be 2. Now, it took 2 seconds for the rocket to hit the ground. Okay, well, that's true, so it's kind of like that question there. The rocket started at an initial height of 30 feet. I mean, it's close, but if we look at the graph, it looks like it started a little bit more than that. So I'm going to say false. It looks like it's about 32. And the rocket was increasing the height between time 0 and time 1/2 seconds. So from here to here was increasing, and that is true. It was going up, it reached its vertex, and it was decreasing. So that is true. All right, graphs are done. Now on to some solving. We have number 20 is 2x squared minus 32. So I'm going to first factor a 2 out and get x squared minus 16 equals 0. The 2 is not going to be it's a GCF, it's like a factor, but it's not going to lead to a solution. So if I divide both sides by 2, it now gives me x squared minus 16 equals 0. This is difference of squares, which we could then write as x minus 4, x plus 4 equals 0, which x minus 4 equals 0 and x plus 4 equals 0 give us a solution of x equals 4 and x equals negative 4. For number 21, this is in vertex form, so we're going to solve by square roots. I'm going to add 49 over to the other side. Now I have a squared equals a square, so I take the square root of both sides. And this becomes plus or minus the square root of 49, or plus or minus 7. So from here I have x minus 1 equals 7, and x minus 1 equals negative 7. So on this first one, if I add 1 over, I get x equals 8. On the other one, if I add 1 over, I get x equals, let's be negative 7 plus 1, so that would be negative 6. So my two solutions are x equals 8 and x equals negative 6. For number 22, we're going to get the squared by itself. So the first thing we're going to do is subtract the 50 to the other side. Then we're going to divide both sides by negative 2, which gets me x plus 3 squared equals 25. From taking the square root of both sides, we get plus or minus the square root of 25, which is just plus or minus 5. So our two scenarios are x plus 3 equals 5 and x plus 3 equals negative 5. The top one gives us 2 by subtracting 3 from 5. The bottom one gives us negative 8. So our two solutions are 2 and negative 8. For 23, it looks like we're going to factor. We're going to multiply to negative 40. That adds to negative 6. I can think of 4 and 10 would give me 40. If I make 10 negative, then it adds to negative 6. So we're taking out an x, and we get x minus 10. We take out a 4, we get x minus 10. Let's not forget our equals 0. So that gives us x plus 4 and x minus 10. So x plus 4 equals 0 gives us that x is negative 4, and x minus 10 equals 0 gives us that x equals 10. So negative 4 and 10. All right, our last set. Which model is appropriate for each set? We have to choose linear, quadratic, or exponential. So first one, it looks like I'm multiplying by 3 each time. The next one looks like I'm adding 3 each time. And then this one, I'm adding 3, adding 9, adding 15, which in each case, I'm adding 6 to that each time. So those are patterns we should look at, and then from there, we just figure out which one is which by its characteristic. So multiplying by 3, multiplying by the same amount each time is exponential. Adding the same value each time is linear. And then having a change that is different each time, but that amount of change is the same. So they added by 3, 9, 15, which is still adding by 6. So that double layer of it is quadratic.